and he's here to talk about something that is a little bit lunatic. Let's see how it goes. Just have fun.
I founded Cislune in 2021, and we're located in Los Angeles, California. Lunar spaceports are the first infrastructure to build for sustainable lunar development and science, propellant production. Tourism will coalesce around these sites and open up our solar system. Yeah, and I worked at Maston Space Systems when I got into the space industry, which is now Astrobotic, one of the commercial lunar payload services companies, and that was 2013 to 2017 in Mojave, California, near where the previous Robopalooza happened. We operated hundreds of vertical takeoff and landing flights with these small rockets that you can see in the photo in the bottom left here. That was a lot of fun and excitement. And then I founded a company that went through Y Combinator startup accelerator, doing in-space chemical propulsion using hydrogen peroxide as the propellant. We have 5 customer satellites in orbit that are using that to get around, move around. And then I started Cislune, and we believe that propellant production is one of the first exports off the lunar surface that'll be profitable after we build some spaceports and infrastructure to start digging that up and mining that material. Cislune's mission is building the lunar fuel factory, and we're working on enabling technologies in construction and mining. Yeah, Cislune has won $4.7 million with 14 NASA contracts and 6 NASA competitions in the last 4 years, finding technologies to live and work on the moon, including working with Pisces on one of our melting of regolith projects that you can see in the bottom right there. Yeah, so it's an exciting time with the SpaceX Lunar Starship set up to be on Artemis 3 and 4. And they just announced pricing for that at, let's see, what's it, $100 million per ton. So pretty expensive to get down to the surface, but that still is 10 times cheaper than the commercial lunar payload services companies were offering for their smaller landers to bring payload down. So it's moving in the right direction. We think that around $100,000 per kilogram is going to be around lunar orbit, but costs really need to come down, of course, for us to be able to do this and being able to build on the moon, use electricity from solar and eventually fission surface power is enabling for bringing the cost down much further. I think one of the big insights that I've thought of is that in low Earth orbit, you just have solar power, which is great, and we get communications, things like Starlink, Earth observation, but on the moon, suddenly we have access to huge amounts of material, and that's what we need to convert into oxygen, gases, propellants, and then hopefully infrastructure like buildings and habitats. So yeah, I mean, the big problem right now is, of course, access to the lunar surface, and to even get out to the moon is requiring the SpaceX Starship operation to consider something like 13 to 20 refuelings by launching new starships and refueling small amounts, and that'll get you to the surface. And without refueling, though, you have to bring all of the fuel that you need to get there and bring the astronauts back safely. So it's a real challenge that I think can really be enabled by what's called ISRU, being able to build on the surface. Just due to physics, the launching from the lunar surface is about 40 times easier than from Earth. We just have a thick atmosphere, which is great to be able to breathe, but it makes it hard for rockets, and 6 times stronger gravity. Sorry about that. next slides. Okay, so Cislune solution is threefold. Autonomous excavation for safe and efficient material removal, and then lunar fuel production through water extraction from the regolith and in ISRU, and then infrastructure building using local resources, whether landing pads, haul routes, stockpiles, for mining and then extraction of things like metals, making bricks, making roads. So this is just one of our projects that's about to finish contracting, but technologies like this do beneficiation after mining to separate out the most valuable minerals efficiently and to be able to do continuous processing to pull out minerals that will allow you to get titanium, aluminum, iron, oxygen, and ice as well. Yeah, this is our first phase 2 project, working with Honeybee Robotics, which is owned by Blue Origin, which is owned by Jeff Bezos of Amazon. And we're looking at percussive excavation, so using percussion, kind of like jackhammering, to reduce cutting forces and react those forces, because with 1/6 gravity, it's a little bit harder to get the impacts to break up the material if the icy regolith is as hard as some people are thinking. And of course, autonomy, like Paolo was mentioning, is going to be very important. You don't really want to joystick all of this from the Earth with a human operator. We need to get to autonomy as quickly as we can for these technologies. Let's see. Anyway, I'm not sure the video will go through, but let's see. Yeah, okay. So this was one of our earlier robots about 2.5 years ago. This is in the Lucerne Valley, just north of the location where the 2024 Lunarbotics competition happened. But we were out here for 3 weeks, so it was quite an experience, doing kind of an analog experience, mining on the moon. And this material looks a little bit soft, but it's just kind of the soft version of concrete, so it was still pretty durable and challenging to get through. And we were filling up these these bucket drums, similar to the IPRAAC or Razor vehicle. And you can see the windows there just so that we could monitor the filling of those bucket drums. But yeah, it's a challenging environment, but a great experience to learn about how to operate in a remote site.
Trajectory doing the excavating.
So this was our updated vehicle, going over one of the 3 different kind of challenging surfaces. I think that was a 20-degree slope, but we were able to navigate that and do all 3 of the extreme maneuverability experiments. So this one was kind of a steep 20-degree load, and then there was, I think, a 15-degree side, and then a large rocks. And so we were able to get through that using our excavator, and then doing 1/6 gravity offset excavations. That was really interesting to accomplish, working out at Huntsville, Alabama, near Marshall Space Flight Center. Yeah, and I'm here at the conference all day, so I'd really like to talk to you more, find opportunities for collaboration, and my email is eric@cislune.com, so easy to get, and reach out if you're out in Los Angeles anytime. So thank you.
So I have a question for you.
Please.
So what would be the competition, I would say, for businesses like yours? How it looks like that?
Yeah, so I guess my last company, we went out and raised funding for in-space chemical propulsion. So I talked to tons of investors, venture capitalists, and it was challenging. So I've been really thankful to have the opportunity to work on these NASA contracts. Haven't decided to make the jump yet to investor funding. Some of the investors have mentioned it's kind of you need to be really doing amazingly well in about 3 years from when you get investment, even a seed stage investment. And I'm just trying to figure out what that timing is, because we're coming up with, maybe in the next 2 years, we'll have astronauts on the lunar surface, which is very exciting, but how do we create a big commercial opportunity within 3 years. I'm kind of trying to stay alive until that timing is right, and then raise funding to go much faster. So it is a difficult timing. There's companies like Cislune in Seattle, United States, that's raised funding for helium-3 mining, as well as StarPath, which is focused also on the ice mining. But yeah, timing these things, similar to like deep space industries, planetary resources, if your timing is incorrect, it's really challenging. So you need to be really careful going to the very expensive money in venture capital. So we're working and trying to bootstrap as far as we can, and then grow from here. So exciting times.
All the best. Thank you.